Charles' law. Charles' law states that at constant pressure, the volume occupied by a fixed amount of gas or the number of mole of gas is fixed, and the constant pressure means the pressure is fixed. The volume occupied by the gas is directly proportional to its absolute temperature. Means when the temperature increases, the volume will also increase. Volume of the gas will also increase. This is a relationship. Volume of the gas is directly proportional to the temperature of the gas, where pressure and the number of mole or the amount of the gas are fixed. V over T equal to K. K is a constant. Volume over temperature equal to a constant. This is the equation for Charles' law. V1 over T1 equal to V2 over T2 means the initial volume of the gas over the initial temperature of the gas equal to the final volume of the gas over final temperature on the gas. Make sure the temperature is in Kelvin. So if we have the temperature in degrees Celsius, you want to convert in Kelvin, just plus with 273.15. You'll get the temperature in Kelvin. This is a graph based on Charles' law. Graph of volume versus temperature. When the temperature increases, the volume also increases. We're talking about the volume of the gas. So this is the graph of V versus T in degrees Celsius. This one is in Kelvin. In degrees Celsius, the volume of the gas is absolute zero when the temperature is at negative 273.15 degrees Celsius. At this temperature, the volume of the gas is zero. For Kelvin, when the temperature of Kelvin is zero, volume of the gas is zero. But for degrees Celsius, when the temperature is negative 273.15 degrees Celsius, the volume of the gas is zero. How the kinetic molecular theory explain the Charles' law? Temperature is a measure of average kinetic energy of the gas particle. Because the temperature, the energy given to the gas particle to move around. The higher the temperature at constant number of mole or amount, higher the temperature at fixed amount of gas and fixed pressure, the faster the particles move and more space they need to move around in to avoid increasing their collisions with the wall of the container. So at higher temperature and fixed number of mole or amount of gas and fixed pressure of the gas at the high temperature, the particle will move faster. And if the pressure is fixed and amount of gas is fixed, if the particles want to move faster, the particles need more space. So that's why the volume must increase if you want to fix the pressure and the amount of the gas. So the volume must increase for the gas to move around to avoid increasing their collision with the walls of the container. Thus, volume increases as temperature increases. This is the figure to show different temperature of the gas. This is 200 Kelvin, this is 400 Kelvin. The initial volume is 0.5 liter, temperature 200 Kelvin. Final volume 1 liter, double of this volume, and the temperature is also double. When the pressure is fixed, 1 atm, 1 atm, if you want to fix the pressure, want to keep the pressure at fixed pressure, but you change the temperature is higher, the gas need higher volume to avoid collision. So the particles at higher temperature need more space to move around as the pressure is maintained. Example, an engineer pumps air at 0 degrees Celsius. Note that this is 0 degrees Celsius. 0 degrees Celsius equal to 273.15 Kelvin. Because in Charles' law, you need to use Kelvin for temperature. So this is 273.15 Kelvin. Into a newly designed piston cylinder assembly, the volume measures 6.83 cm cube. 6.83 cm cube equal to 6.83 mil. At what temperature in Kelvin would the volume be 9.75 cm cube? This is the initial temperature 0 degrees Celsius, initial volume 6.83 cm cube. The question asks for the final temperature given the final volume. So write down all the information first, convert the temperature into Kelvin. We need to find the final temperature T2. So using the Charles law, V1 over T1 equal V2 over T2, where the amount of gas or the number of mole of the gas and the pressure are fixed. So T2 is equal to substitute all the values into this equation and you will get the temperature in Kelvin is 390 Kelvin.